Well, once again, good morning, everybody. This is Frank Wouters. I'm the director of the EU GCC Clean Energy Technology Network, a political institution that fosters partnership between Europe and the Gulf. We have some funding from the European Commission to do that, and we're focusing on the energy transition. And part of that energy transition is hydrogen as one of the new drivers to move energy from A to B, to produce energy and to use it in new ways, in a cleaner way, hopefully. And it's my pleasure today to have with me Paul van Zon, President and CEO of DII Desert Energy. I'm not sure he needs much introduction. He's been around for a long time. I've known him for almost 30 years. We've worked together on wind in the early 90s in Germany, and we're still working together, so there can't be that much wrong between us. And of course, Driss Bravo, who is Executive Manager of Business Development at Aqua Power, the leading developer in the region, and now also working on hydrogen, clean hydrogen, as part of their portfolio. The schedule of today is that we'll have two presentations, after which we will have a Q&A session. Please share your questions that you may have either in the chat box. It would be interesting for us also if you can briefly introduce yourself so we know who you are and where you're from. So you can either use the chat box or the Q&A. The sessions will be recorded and we will make the presentations available on the ATA Insights website later this week. And with that, I would like to give the floor to Paul. Paul, the floor is yours. Please take us through what DII Desert Energy is doing. Please unmute, Paul. We cannot hear you.
Can you hear me?
Yes, we can. Thank you.
Thank you, Frank, for your introduction. And as said, I will walk quickly through a few sheets just to highlight where we stand in DII, what was called in the early days Desertec, and how also we are now embracing hydrogen and work with the international community to bring hydrogen into the market in North Africa and Middle East. So let me see if I can get control now of the sheet. The arrows are not
I have given
working.
you more control. Let me try it again.
Do I have remote control now?
I done it again. Paul, can you try?
I try again. No, I have no remote control.
Okay, let me just do it. Just tell me.
So, yeah. Well, we wait for the, in the old days, we had the overhead projector that didn't work. Nowadays, we have the arrows that do not work. Let me see. Well, that's it doesn't seem to work.
You're right. It doesn't. Let me try once again. I don't know what's happened now. It worked perfectly before, and now we're struggling. Okay, here we go.
Okay, well, what I said, it's about this early days Desertec. In the meantime, we moved or we evolved from the old, and you can skip to the next one, Berlin. This Desertec, like 10 years ago, in, I would say, 2009, we started, especially with the German idea, to import electricity, green electricity from the deserts in North Africa and Middle East. That focus was a little bit too rigid, and after a couple of years, and some studies and all that, we then moved this initiative of the industry to the region. We moved actually to Dubai and focused first on developing a market for green electricity in the region. So that's the first thing to do before you can export anyway. And where we stand today, what we call today Desertec 3.0, is to look at the region, North Africa, Middle East, the desert region, like how can this region be developed to create actually, first of all, to bring the energy transition in all the countries in the region to as quickly as possible to an end, so to make this region emission free, and also to make this region a so-called powerhouse to the world, not only to Europe, but to the whole world. And not only electricity, but also green electrons like hydrogen. So this Desertec 3.0 actually is a very important point. It is not an initiative of Europe or United States or China. This is about the countries in MENA, like Saudi Arabia, Morocco, Algeria, UAE, and so on. They are in the lead, the public and private sector. And the target is actually to become a big powerhouse, yeah? To mobilize all forces in these in the region to be able to green the region. And also very important, that was not so much in the early days, like 10 years ago. Nowadays, we look very much like the first thing, what are the local benefits? Jobs, industries, synergies, working together, and so on. And last but not least, on this, you are too quickly, very important. It should be a very natural development based on bankability, based on economics, on commercial processes, on supply and demand, of generation, of flexible demand, of conversion to green molecules, of connecting markets, so import, exports, exchange of power, exchange of molecules, and also storage of electrical power, storage of thermal energy, hydro reservoirs, and so on. So it's a total holistic view on all the elements that should all fit together. So now you can go to the next sheet. Many people always think that, especially outside of the region, that there are no projects, it is only at the very beginning with renewable energy. That's not the case anymore. We are quickly now moving to 20 gigawatts, and there are already many installations in operation, and a lot of projects are being announced or are planned. They may not all be built, but in any case, in DII, we have a database and we monitor about 1,250 projects at the moment in the whole region. This is wind, solar PV, solar CSP, and also hydro. And then also electrical grids. Originally, there was a big idea to build big grids from A to B between North Africa, Middle East, and Europe and beyond. This development did not go very fast because in the last 10 years, there was also not really a physical need for a lot of power exchange. This need will grow, that's our expectation. If there is more power generation in North Africa, Middle East, then there will be more fluctuations of solar and wind. It's a very volatile production. There, the interconnection will get a higher value, and we believe that in the coming decades, a lot of grids are being built. Very interesting examples where DII is involved is, for instance, a cable study between Morocco and the UK, and a cable study between the UAE and India, just to give you an idea. And also potential connections to Sub-Saharan Africa, which we mainly study with one of our shareholders, State Grid of China. Next sheet. Then about the Hydrogen Alliance, I think just want to highlight this. I have more sheets later on, more in detail, which I will not present at the beginning because that would take too much time. But just to highlight, Actually, Frank Wouters, our moderator of today, came to us about a year ago with a brilliant idea to set up a hydrogen alliance and promotion, hydrogen promotion engine for the region. And that's what we took in DII together with Frank Wouters and other people, like, for instance, Ad van Dijk of the Technical University of Delft in the Netherlands, and with Hydrogen Europe. And we started actually really beginning of this year, hosted by Masdar. And ever since we have had several meetings. Nowadays, we have, if we have online sessions, there are always at least 400 participants. And we have a long list of companies that are now partner of this Hydrogen Alliance. Next sheet. This list of the companies, just to give you an impression, Aqua Power, of course, and actually the big important players in the field are like also Neon of Dris, of course, prominent partner. ThyssenKrupp, for instance, very interesting is that we see now also more involvement of the big steel factories. They are looking for hydrogen, green hydrogen, will be one of the big off-takers. So this is all give you a view of the activities under this Desertec 3.0 in the region, where we bring the public and private sector and academia together. Next sheet. We have also produced in the meantime 2 very important papers. The first one you see on the right, it was November of last year. Together with Irizen in Morocco, we drafted an idea, so-called Europe Hydrogen Manifesto. It is to connect the market for hydrogen in North Africa and Middle East, actually, and with Europe. And this was then later on in April, to our great surprise and also our great happiness, embraced by the European Commission. The vice chairman of the European Commission, Frans Timmermans, took this idea and said, well, this is great. This 2 times 40 gigawatts, so 40 gigawatt Europe, 40 gigawatt North Africa. I take this in the strategy of the European Commission of Europe. Actually, this is one of the biggest initiatives in the world actually on hydrogen now, that the Green Deal of the European Union included or took this idea of hydrogen North Africa and Europe of DII, together with Ad van Dijk and Frank Wouters and all these people, as part of the strategy, which is a big success. So next sheet. To give you an idea like how this could be developed, how could be started, the connection between the market for hydrogen that is emerging in North Africa and the market of hydrogen in Europe. Assuming that there is much more demand in Europe and more supply in North Africa, the question is how you bring hydrogen or other green molecules like ammonia or synthetic gases and fluids from this region, North Africa, to Europe. One very obvious first step is to use the existing gas infrastructure, but maybe also infrastructure for oil and fluids. And this gives you here an idea of the grids that are already there, starting in Algeria and in Libya, and then pipelines to Spain and Italy. But there are more pipelines in the eastern part of this Mediterranean. And this existing gas infrastructure can step by step be used or take hydrogen on board, so just by a mix of natural gas and hydrogen, and taking them more and more hydrogen. In the coming decades, dedicated infrastructure for hydrogen will be built, or for other gases and fluids. That's actually the idea, and that's what we are working on. So the next sheet. So if you look at what are local projects, what is first of all going on in the local markets? The first step, of course, is that if you have a local hydrogen production, then you substitute the hydrogen needs locally, like in Morocco. For instance, if you have fertilizer factory that needs hydrogen or ammonia, that you take this local hydrogen first before you start thinking of exporting. And then you look for what is the market potential in your own country, in your neighboring country, in the world. And that's where we stand today. We are at the very, very beginning. So this market for hydrogen, you can see this on the bottom. It really started a little bit of, like if you talk about green hydrogen, only 2 years ago. Tata Steel and Dow Invest and ThyssenKrupp and GasUnie in the Netherlands and TenneT, these are the first movers, the pioneers. But where we stand today, we have already seen that the European Commission have assumed this in its strategy. We see also larger announcements of projects like Shell and big players in Europe, but also the Morocco and NEOM, and we will hear this from Driss later on, in Saudi Arabia, and also in Dubai, where we see initiatives. So from the current situation, where we see that this is really at a very early stage, where players are starting to come up with ideas, where governments have a little bit of money and they put this in their strategy. Also, Germany has a hydrogen strategy. The Netherlands took it. UK has. They all start having now hydrogen plants and also subsidy schemes. The outlook, I think, is that the market potential for hydrogen will be huge. At the end of the day, hydrogen will be a very integrated element in all the emission-free, there's a net emission-free value chains in the world of energy. Each country, one way or the other, will be dealing with hydrogen. And the target actually also for us as DII in this year and in the coming years is to gather knowledge, to bring parties together, to develop concepts about the markets, about cost modeling, about business cases, about getting this done, about identifying obstacles. And then once we have identified obstacles, how to remove them, to perform all kinds of studies and so on. So then the next sheet, this whole development, and also what we talked about, Desertec 3.0, not only electricity from the markets in North Africa, Middle East, from the deserts, but also so-called green molecules. How this will be developed, what are the perspectives for the region, and the idea of a powerhouse is all be captured in a book that we wrote last year. That is myself and Thomas Isenburg. Thomas Isenburg is a German journalist who helped me to bring all this information together and to also outline the perspectives and projects and vision for the coming decades. I can recommend, of course, anyone. This is a sort of marketing, so to say, for my book. Also for the Maghreb friends, we are now translating this book into French. So this Morocco, Algeria, and Tunisia and Mauritania, they can also then enjoy this book. So for this moment, Frank, I only highlighted this. I have more detailed sheets if this would bring or add something to the discussion. But for the time now, I think that Driss has even more interesting story to tell.
No, thanks, Paul. Thanks very much for that, for those great insights and the latest on DII Desert Energy. Just a reminder to everyone, I see we have participation from as far away as Hong Kong, Tanzania, Afghanistan. So it's really great to see that this topic basically chimes with so many people all over the world. Again, please share your thoughts and any question you may have on either the Q&A or the chat. We will monitor that. So after the two presentations, we'll have an opportunity to go and do some more digging into the topics. With that, I would like to give the floor to Dris. Dris, the floor is yours.
Thanks very much, Frank, for the introduction, and I'm very pleased to be joining today the webinar. Okay, could you please confirm that you can see my screen?
Yes, we can. We can.
Okay, perfect. Thank you very much. So good morning, everybody. Real pleasure to be here today, joining this webinar on a topic that is that we see being very exciting, which is the development of green hydrogen, especially in the MENA region. I think that we are currently working with great partners on a very great adventure, which is this NEOM Helios project, trying to bring effectively the world's largest green ammonia project to the world. This initiative is a joint initiative between Air Products, NEOM, and Aqua Power. So I think that both the three partners are bringing a lot of value with each of their, I would say, key advantages and prerogatives. Air Products being, of course, one of the leading industrial gases companies in the world, and for sure a leader when it comes to the hydrogen. NEOM, I would say, developing one of the most innovative and I would say area of the world, and benefiting from amazing renewable resources that are a key contributor to the feasibility of this project, and a modest contribution from Aqua Power on the trying to deliver the best value on the generation side, and where we see that it's really the key feature of generating competitive green hydrogen. So maybe in first instance, let's try to address a question that may be raised by the audience around why Saudi Arabia in general and why NEOM in particular has been chosen as the location for the project development. I think that first of all, Saudi Arabia as a whole, I mean, benefits from a tremendous potential in terms of renewable energy resources. Solar is the most obvious one that comes to everybody's mind, but there is as well one of the best wind resource potential in Saudi Arabia, especially towards the western coasts. And NEOM in particular happens to combine both in a way that effectively provides one of the best combination of both solar and wind, delivering capacity factors that are effectively unseen elsewhere in the world. So that obviously is a key contributor to delivering a high capacity factor renewable mix and a very competitive base on the electricity, which is the main input towards producing green hydrogen through electrolysis. Of course, there is the geographical location, which is at the heart of very established shipping routes for the key markets that would be targeted, I guess, by the green hydrogen in the future, or it could be Europe on the Far East. And finally, Saudi Arabia as a whole benefits, of course, from a very well-established position in investing and exporting energy and chemicals. Of course, I mean, we all know that Saudi Arabia is one of the largest energy exporters in the world, a key player in the petrochemical industry, which means that there is an established supply chain in the country to build and operate very large-scale energy and chemical complexes, a very favorable tax and regulatory regime, and as well a lot of in-country expertise in terms of developing, structuring, and financing complex energy and infrastructure projects. And I believe that this was one of the a good summary of the driving factors, I'll say, beyond the ambition and visions of the partners coming together. So what is this project effectively? The NEOM Helios project has the ambition effectively to invest into approximately $5 billion to put together a world-scale green ammonia production that will be exclusively powered by renewable electricity located in NEOM. So of course, so it will effectively combine a number of technologies in order to effectively produce all the necessary utilities and inputs to the production of this ammonia. That will include, of course, the power generation based on the renewables. Of course, some water generation, of course, because we need water to produce this hydrogen. The hydrogen electrolysis and the ammonia synthesis, of course. A very important feature of the project is that there is an offtake that is already established as part of this project, and there is the key enabler. So our partner, Air Product, is taking the leadership in being the sole offtaker for the whole ammonia production that will come out from this project, and that will later on distribute it to the international market, and for which I can provide a little bit more information. So by producing approximately 1.2 million tons of ammonia per year, I think we expect to be online by 2025. So I think that in order to come up with such a concept and make it a competitive solution, of course, the first basis was on the availability of the resource, as I've mentioned, whether of solar and wind, but as well in putting together a conceptual design to achieve really a cost-effective solution to generate ammonia that is powered 100% by carbon-free and sustainable electricity based on renewables. So I would say the value chain, of course, starts from the generation of electricity with the combination of solar and wind at gigawatt scale. We integrate as well energy storage. That is effectively a key enabler of, I would say, of stability, and as well as maximizing or stretching out the availability of renewable electricity to operate I would say, the processes to generate hydrogen and ammonia. Of course, the core of the project here is the hydrogen generation, and that is done used through water electrolysis at gigawatt scale as well. And of course, we will have a world scale, I would say, both air separation unit and ammonia synthesis loop to combine the hydrogen with the nitrogen and produce that ammonia that will be then transported once by Air Products and distributed to the rest of the international market. So I think that the ambition of the project is really on terms of scale is to be able to effectively deliver the necessary economies of scale to make the project competitive, and as well, I would say, save a substantial amount of CO2 emissions. We're talking about close to 3 million tons of CO2 per year. And I believe that the key target of our partner Air Products is effectively to address the mobility market, and especially the heavy mobility. So as I have mentioned to you, so the NEOM Helios project scope is effectively the generation of the ammonia that will be based from the combination of wind and solar to generate hydrogen, which is the main power consumer, and ultimately synthesize ammonia. And then our partner Air Products will take care of effectively distributing the ammonia, and which ultimately will be dissociated into hydrogen in order to effectively address the mobility market. And this is where we appreciate very much effectively the leadership position and the view that has been taken by Air Products to enable the project and really position itself as a leader for the hydrogen distribution for the mobility market. And that's and that's it, Frank. That's thank you.
Thank you very much, Driss. That is very insightful. I think it's fair to say that this is at the moment, you know, the largest live green ammonia project in the world, and probably the largest, you know, live even green hydrogen project in the world. Because I mean, there is bigger ones in the pipeline. Paul mentioned the Shell initiative in the north of the Netherlands. but they're still very much at the early feasibility stage, and this seems to be further advanced. Dries, maybe a quick question on the ammonia cracking, because I mean, that is obviously a key point. You have with ammonia relatively low cost transport, but at the same time, you still then for transport you need very pure hydrogen. Can you tell us a little bit more about the technology that that Air Products will use for that, or is that something that is outside of your scope?
Yeah, unfortunately here, Frank, this is what I will have to refer to my colleagues from Air Products to give better insight into that. But I believe that they have very clear views as to how they want to implement that. And this is clearly the driver that has effectively enabled effectively putting together an offtake already for such large quantities of ammonia produced in NEOM.
Okay, good, fair enough. So there's a couple of questions that are also asking about the availability of the presentation material. Yes, they will be made available on the ATA Insights website, as well as the recordings of this whole webinar. So everything will be made available probably somewhere at the end of this week. Paul, there is a question about basically the business case. If you look at hydrogen for power generation, mobility, and industrial application at the moment, it's more expensive. So how do we overcome that? Can you give your views on that? Paul, you have to unmute yourself. I can do that for you, I think. No, I can't. Again? There you go.
Now, can you hear me now?
Now we can hear you.
Okay. Well, this is a question that we always face in the beginning of a market. I mean, there is no demand, no supply, supply demand doesn't work. Normally, the product costs are relatively high at the beginning, low volumes and all that. So to overcome the first steps, normally you would need support, so government support, or investors that believe in this and put some money and bring us to a certain level. And once this market is starting and demand is growing and more volume is being produced or more capacity is being built, you get economy of scale. And then you may hope, and it is actually very important, that we have a good view on reaching this point in which the product will be competitive in the framework of the total energy chain. If a product would never have a chance at the beginning, Sean, to become competitive, to lower the cost or to add something to the value chain with the value, then you better stop and don't do this. A very important point if we talk about renewable energy, on the one hand, renewables are these days like solar and wind very, very cheap. So they have reached already very soon and much sooner than we thought 10 years ago, a level of competitiveness on their own. But also important is that if you talk about competitiveness, you do not compete to harmful products like oil, gas that send their emissions in the air and then poison or bring a lot of harm to our planet. So it's very important that not only you look at lower cost on the one hand, but also avoid or bring or reduce actually harmful emissions. It's very important that emission is being penalized or even prohibited in the coming decades. So that all these elements help a market to start, especially hydrogen.
Thanks, Paul. Dries, there's a lot of questions on your presentation. Could you maybe allude two things? One is, why did you choose the ammonia route, and why not, for example, liquid hydrogen? Because that is in the end what Air Products seems to want to have. And secondly, there's a question about the various roles of the project. Is it going to be one partner. Who are the partners? Can you explain a little bit more about that?
Thank you, Frank, and thanks for the question. I think that the reality is that as of today, I think ammonia is a product that is very well known, traded, transported throughout the world, for which there exists supply chain and a number of technology in order to produce it and move it around on a very conventional basis, which is not available when it comes to liquid hydrogen. So I think that it was only a few months ago that you had the first, I would say, pilot ship to try out effectively the transportation of liquid hydrogen. And effectively, it's a technology that is very immature, I would say, not yet sound and not yet commercial. So I think that maybe in the future this will become effectively the norm. But I would say in the foreseeable future we don't see it yet coming up as a solution. So I think that's why we certainly think that ammonia is a very elegant solution in order to effectively act as a carrier for hydrogen and make it accessible from the places where the hydrogen can be produced at the most competitive rates. Thanks to effectively the availability of solar and wind resources, and make it available where the demand is the most available on I would say for the hydrogen.
Thanks. There is also a question. I mean, it was something that Paul mentioned, but maybe Dries can answer that. You know, when we're talking about the investment point of view. But what about the overall lifetime cost of the product? Can that compete with fossil fuel alternatives? I mean, how do you see that?
So you mean on the price point for the hydrogen? This is the question, right?
Yeah.
Oh, I believe that. I think that the specifics, I would say, of hydrogen in particular, is that, of course, I mean, scale matters. So you have a combination of course, the availability of the resource, as I've mentioned already. And there are a few places in the world that benefit from unique resources and make them pristine locations to produce, I would say, hydrogen at competitive rates. NEOM is one of them. The scale as well allows effectively to take the best benefit from the technology and as well on optimizing the cost. And all of these I would say factors are combined all together in addition to the environment for the investment to be done. And that's why I was referring earlier to the very favorable, I would say, investment environment in Saudi Arabia, where it comes from I would say, the confidence of investors to raise money and invest large quantities in complex projects that is available already, or on the tax or regulatory regime. All of that combined together makes it, I would say, a very attractive proposition to generate a competitively priced, I would say, green hydrogen.
Thank you. There is also a lot of questions about, you know, the inter-regional exchange of energy. And Paul, this one is for you. First, there's a technical question about the suitability of the pipelines. I think I can answer that. There is sufficient evidence. You know, studies have been carried out in Germany, the Netherlands, and in France on the materials of the pipes, on the flanges, you know, the gaskets, the compressors, etc. It is feasible for the large majority of the existing pipes to be converted to hydrogen. Obviously, you need to modify some things. I mean, you need different compressors and flow meters, but by and large, the cost of using an existing gas pipe is a fraction of the cost of a new pipe. So that is something that we can take into account. But then the second question is, for that to happen, you need trust between countries and regions. And that is not a natural given. Especially perhaps everybody's watching the news. International trust is not something that is going up, rather going down. So how do you see that, Paul? How can we make this a success if we are indeed exchanging you know, renewable hydrogen between countries in MENA and then potentially from MENA to Europe? What do we need to do to make that work?
Yeah, I think you mentioned a very important principle, that is trust. If we talk about a global market or an international market, then of course one of the things is a trade and investments, investment climates, and investment climates and trades all need trust and agreements and a certain mindset. That's a mindset that is under pressure internationally. That's right. But if we look at Europe and North Africa, I think the mindset is well enough. And also we see in NEOM, for instance, in the infrastructure in the GCC countries, there is still a more than sufficient basis for international trust to invest. For knowledge transfer and to build infrastructure, and also to bring this supply and demand together. Like the risk is a very good example of an initiative in NEOM, Saudi Arabia, to start this process and to say, well, we will simply produce, we will build renewable energy. This is number one, very important. So you have to invest. It is something you do only if you know, have a trust that you need this for many decades to come. Otherwise, you would never do this. And then you say, well, a part of this energy we use, of course, locally, electricity, but also a part is then for producing a product that we bring to the world market. And then we include partners that bring this product to the world markets, like our products. That's a very good example. We see this in a small scale, in a medium scale, and large scale in North Africa and Europe. The fact that Frans Timmermans, the vice chairman of the European Commission, took this subject and said, well, I include this in our long-term strategy of Europe, European Union. I mean, you can have criticism about the European Union. You can say, well, the countries have all their own hobbies and their own ideas, and they never are aligned. That's not true. In Europe, there is alignment on the big thing, at the big level. There is a framework for investments, and there is also some money to start this. So there is some money mentioned for subsidization and so on. So it's a gathering of different elements that should be based on trust in the future. And we hope, of course, that we will not have too many or not at all conflicts. Conflicts in the region are, of course, always a pressure. But I'm optimistic, especially in the Maghreb and the GCC countries and Egypt and Jordan. We see a great movement on the renewables. And we will see also with the help of the big initiatives of NEOM and IRISM and MAZEN and others, we will see also in hydrogen the same thing happening.
But I mean, we look at, on the one hand, if we're talking regions, we have the European Union, which is, you know, a very complex system with a lot of bureaucracy, but at least it works. You know, people are working together. There's an open market for energy, etc. And then there's the realization that if Europe wants to go to a net zero carbon energy system, which is a declared goal, you know, you will still look towards importing energy. Right now, Europe imports more than 50% of primary energy. That's, you know, gas from Russia and oil from other places. But even in the future, when we will have a system based on renewable energy and potentially hydrogen and other things, that will not be all from Europe itself, but it will have to be imported. Now, there is a question, is that going to be, how is that going to be organized? If we're talking about trust, you're talking also about country to country or region to region agreements. Is that something that the European Commission, on behalf of the European Union, is going to do with MENA or with Maghreb or with individual countries? I mean, can you maybe share your thoughts on that?
Was the question to me or to Chris?
That was to you, Paul.
Okay.
Yeah.
Well, first of all, like we talked about the hydrogen strategy of the European Commission of the European Union that simply adopted this hydrogen and adopted the idea to import this from North Africa, among others, by the way, not the only thing. So that will is a framework. I think we should not dream this will work. It is very important also that there is a interaction between bottom up, like the NEOM. NEOM is in that sense bottom up from a global point of view, and also Irizen in Morocco and so on, and also a top down that there are frameworks at a high level like the European Commission and the Arab nations are also talking like, can we start organizing this? Is in the Arab world a little bit more difficult to get all the countries together, but it is also there something that is in movement, in progress, and this together, so a top down and bottom up, will then bring this process ahead. And especially, like I mentioned before, very important is that this creates business cases, so that commercial parties see there a business. Once commercial parties will see business, this will move. They will put pressure also on the political arena to facilitate this. They will see bottlenecks, like they want to make projects and they see problems with projects or problems with bringing the product in the market. And once this process is starting, they will push for the politicians to improve frameworks.
So it's a public-private
public-private interaction. Yes.
Yeah. When we spoke with Frans Timmermans in November, I think he mentioned the same thing. This is not something, these kinds of very big transition elements, they cannot be done by the private sector alone, and they cannot be done by the public sector alone. So this needs to go hand in hand in a smart way. I have a question for both of you. Somebody mentioned there is some talk about extending to sub-Saharan Africa. Why is that only an extension, and what are the impediments for such kinds of investments in sub-Saharan Africa at this point in time? Maybe Driss, you can start. Do you have any view on that?
I believe, like I said, the key thing when it comes to especially for green hydrogen in the immediate term is really finding the right locations to produce in a competitive way to make it a reality. And I think that effectively we will see, starting with the locations that have, I would say, the best resources and as well the best, I would say, environment to invest for such large projects that involve quite substantial infrastructure to be built in order to make them a reality. And progressively, as of course the technology matures and the market becomes, I would say, wider, I'm sure that the number of locations that will become relevant will only increase. And I'm sure, so accordingly, I don't think that there is a limitation geographically over the long-term future expansion of the I would say the producing countries, but it's really a more of a I would say kind of a process that we will have to follow, and the market will naturally select those best locations to start with before moving, I would say, to those other locations. Where sub-Saharan Africa sits, I think it's on a case-by-case basis. I don't think there is a wider kind of perspective around that. Some countries may have great potential, some others may not make sense at all, and that has to be really looked at on a case-by-case basis.
Well, that's right, what Driss is saying. In addition to that, we work, as you know, a lot with State Grid of China, with GuideCo, the global energy interconnection organization. They have a big master plan for Africa, actually, especially coming from the big hydro sources, like in Congo River. And they have plans to connect these regions with major hydro, not hydrogen, but hydro production with the neighboring countries, and at the end of the day among or between continents. And nowadays they're also looking at developing hydrogen production in the regions with very cheap hydro production. But the same will happen with solar and wind.
Thank you. In terms of Paul, you mentioned a few times, you need a business case. At the moment, we know that because it's early days, we haven't reached the scale yet that we need to get to cost competitiveness. What are the first things to do for both the public and the private sector to get a business case where the business sector can make an investment decision that makes sense?
Actually, that's right. I think the private sector is very simple. The private sector has a purpose. One of the purposes to make profits, to make money, and they can only do this by so-called business cases. That means that they invest in an activity and then must be sure or must have a belief that they will have a return that is interesting enough. And in new products like hydrogen or green hydrogen, we talk about green hydrogen here today, that may not yet be the case. So, and there we start with the whole interaction between public and private. If there is not in your country or in the area you are not yet a clear business case to invest, for instance, in electrolyzer or in infrastructure for hydrogen, then this is something to take up with the first of all the national, the local authorities to find out if there is an interest, if there is a encouragement from an incentive from the government. That's important. Otherwise, there would be no business case. The other, like we see in NEOM, for instance, there it is a little bit larger setting. That's of course the government or the authorities, the public sector, but also the private sector itself says, well, we also believe in this and we want to give this a push. So the first investments or the so-called non-economic part of the business case could be supplied in the beginning also by the private sector itself. It's a business decision. It's first of all, this whole hydrogen movement is, of course, to add to the climate issue, reducing emissions. That's actually one of the big drivers of hydrogen. Otherwise, we would not talk here about hydrogen with this enthusiasm here today. And this is really something where government should have some role. They should put pressure, they should believe in this and make this happen.
Thanks. And how important is a price on carbon in this whole transition for both of you?
Yeah, there is.
Listen, Frank, I think that as Paul has mentioned already, I think that we are sitting here today talking about green hydrogen for the simple reason that there is a strong drive to decarbonize. That is the key thing. And I think that green hydrogen is offering a great opportunity to decarbonize in many aspects that effectively up to now we were not effectively looking at, simply because technology was not available beyond the willingness itself. And I think that green hydrogen today is starting to become a sensible solution because of the, I would say, the technology readiness to address especially the heavy industry, I would say, emissions and other heavy transportation, for example. But as well that the cost is now starting to reach a point where it starts making sense, simply because the actual source, which is the renewable electricity, has reached levels that were not even foreseen to be reached within the timeline where we are today. think that, if I'm not mistaken, in 2010, if you would be looking at the projections from the IEA about where solar energy should be in 2020, it actually happened in 2015 or maybe mid-2014. So obviously that there is a dramatic change that, of course, we all have to adjust to, and this is exactly what is happening. And this is where we see as well that policy should be flexible enough to effectively listen to the market and take the best out of it in order to drive the policy for the future when it comes to things that are as important as energy. On the carbon pricing, if you want to have competition has to be fair. Europe is all about having a fair competing ground when it comes to I would say, various industries. And I believe that on the energy sector, I mean, allowing competition is allowing a fair competing ground. And the true cost of, I would say, using certain energy sources is, as of now, underestimated. So, of course, carbon pricing is a way of equalizing effectively the level playing field and allowing, I would say, the various energy sources to compete in the true value they are delivering. So carbon pricing has to be there. It is there, but it's maybe not sufficiently, not set at a level that effectively is a true representation of the environmental cost. It will be definitely an enabler to accelerate at the beginning, but I'm quite confident, quite frankly, that the market as well will naturally move towards the direction that we're trying to push it towards now. Again, because innovation and scale, in the same way we have demonstrated it on the renewables, will deliver the same value on hydrogen ultimately. And it will become irrelevant as a discussion. But as the beginning right now, really to truly unlock the potential, it is definitely something that is required to be looked at in a fairer, I would say, manner.
I think Dries said it almost all. He said one very important point is about acceleration. I think the carbon, on the cost side, the technology and market as such, hydrogen, green hydrogen, it will find already today, irrespective of the carbon price, business cases in the world. I mean, that's for sure, because of the very, very low solar and wind production costs. But if we want to get rid of all kinds of harmful emissions, then we have to put more pressure on this, and that can be done or must be done by carbon price or even prohibition of carbon emission. At the end of the day, we should not allow carbon emission anymore if we know that this destroys our environment. It is, of course, very high level talking that we are doing, and it will be almost impossible in the world community to enforce something like no emissions. We all understand this, but to have this in mind and as a sort of purpose and objective would not hurt.
Thanks. Then there is, and I think we're reaching the end, but there is an important question here about water. I mean, especially Saudi Arabia, one of the few countries in the world without rivers, and I think largely depleted fossil water reserves underground. So most of the water you need to desalinate it. Can you maybe allude a little bit to that point, which is obviously very important, especially in desert areas where water is a scarce resource?
Yeah, so I'll take that one. I think that there is always a lot of concern when it comes to the accessibility to water. I mean, first of all, I think that if you really look into the details, you'd be surprised about how, I would say, maybe little water you're using to produce such vast quantities of hydrogen. So I think, first of all, I think that this is fully taken on board into consideration, especially in the NEOM project, given the scale. And you'd be surprised to see that actually the water quantities are quite small, despite the very large scale of the project. So I think that is the first thing to maybe to put a bit of perspective on how much of a concern it should be. Now, there is still water that is required, and of course it needs to be provided in a sustainable manner. So of course I think that as part of the mandate of NEOM anyway, the water will be effectively produced through seawater desalination. That will have to be powered exclusively by renewables in the same way that the overall concept is powered by renewables. So I think that is not an issue. And I think that in the specific case of NEOM, I think that there is even like one extra, I would say, requirement that is pushing the bar even to a higher level when it comes to the sustainability, is that the future developments of seawater desalination in NEOM will be based on zero liquid discharge back into the sea. So I think that from a sustainability perspective, I think we're quite confident that the solution that is being put on the table is effectively really reasonably set to minimize any harmful impact on the environment, not only from a CO2 perspective, but as well on the water production.
Yeah, no, I think that's an important aspect. And as you rightly say, I mean, if you look at the overall amount, I think I've seen a calculation where if you were to completely replace all fossil generation that we have right now with renewables and hydrogen, you would overall require less than half of the amount of water that is currently being used in the power sector, because all the thermal processes that we have, they require cooling. Obviously, the issue is that we may, find different locations, because right now you build a, you cannot build a nuclear power plant in the desert where you have no cooling water, so you always have it by a river at the sea. With the renewables, you may be better in certain locations where you're further away from water, so you need to pipe in water. So the actual location of where you're going to do things will require due consideration. But I think overall it's an important topic, but not something that is a major impossibility to overcome. And with that, I would like to thank the speakers and, of course, the listeners, the organizers, MESIA, the Middle East Solar Industry Association, as well as ATA Insights. Once again, we've recorded this. The presentations will be made available roughly around the end of this week. So have a look at the website, ATA Insights. And once again, thank you very much for this very insightful webinar.